This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on derivative rules. So earlier we did the definition of the derivative. These will be some shortcut rules that will get us answers faster. The power rule. The derivative of x to the n power is n times x to the n minus 1. This will enable us to take derivatives of polynomials and polynomial-like functions. So there's our power rule. We want to take the derivative of x to the 7th. So n is 7, and minus 1 would be 6. So that would be 7x to the 7 minus 1, or 7x to the 6th. So there's our power rule for that expression. Next up, we're going to take a look at the derivative with respect to x at the square root of x. Now this is not a polynomial, but we can rewrite the square root of x as x to the 1/2 power. That would enable us to use this power rule. So I've got the derivative of x to the 1/2 power, so n is 1/2. The derivative will be 1/2 x to the 1/2 minus 1 using this rule. Pulling the 1/2 down, decreasing the exponent by 1. 1/2 times x to the 1/2 minus 1. A half minus 1 is negative a half. But now what does x to the negative 1/2 mean? When you see a negative exponent, that means it's in the denominator. That would be 1 over x to the 1/2. So we get 1/2 times 1 over x to the 1/2. But x to the 1/2 is the square root of x. So we become 1/2 times 1 over the square root of x, or 1 over 2 root x by the time all is finished. Again, with our power rule, I want to take a look at the derivative with respect to x of 1 over x to the 9th. Again, not a polynomial, but we can write it as x to the n power. 1 over x to the 9 is x to the negative 9. So we have the derivative of x to the negative 9. Pulling the exponent down, n is negative 9. X to the negative 9 minus 1. Negative 9 minus 1 is negative 10. So we get negative 9x to the negative 9 minus 1. Negative 9x to the negative 10. But what does x to the negative 10 mean? It means 1 over x to the 10th. So it's negative 9 over 1 times 1 over x to the 10th. Multiplying the fractions, and we get negative 9 over x to the 10th. So these are all examples of this power rule. The derivative of x to the n and x to the n minus 1 enables us to take derivatives of many, many functions. Now, our next important rule is the derivative of f of x plus g of x is the derivative of f of x plus the derivative of g of x. Shortcut form is to say the derivative of the sum is the sum of the derivatives. So how are we going to use that? I want to take the derivative of x to the 5th plus x to the 11th. So that would be the derivative of x to the 5th plus the derivative of x to the 11th. That's all we have to do. And then with our power rule, the derivative of x to the 5th would be 5x to the 5 minus 1, 5x to the 4th. The derivative of x to the 11th would be 11x to the 11 minus 1, 11x to the 10th. So again, the derivative of the sum is the sum of the derivatives. That is a helpful rule for us to use. Again, looking at this rule, I want to look at the derivative of x to the 7th plus 1 over x to the 4th. And you may think that's a quotient, so you have to use the quotient rule, but actually not. There's a common denominator, so we can think of this as x to the 7th over x to the 4th plus 1 over x to the 4th. And then the derivative of the sum is the sum of the derivatives. X to the 7th over x to the 4th is x to the 3rd, and 1 over x to the 4th is x to the negative 4. We have an exponent in the denominator, we can think of that as a negative exponent. At this point, we're ready to go ahead and use our power rule. So the derivative of x cubed would be 3x to the 3 minus 1, 3x squared. The derivative of x to the negative 4 would be negative 4x to the negative 4 minus 1, or negative 4x to the negative 5. X to the negative 5, of course, means 1 over x to the 5th. And then multiplying 4 times 1 over x to the 5th, we'll get 4 over x to the 5th. And my answer for the derivative of this original function is 3x squared minus 4 over x to the 5th. Now, I can get a common denominator if I want, and some computer adaptive learning systems insist on that. So the common denominator with these two things is x to the 5th. So I'm going to multiply that first piece by x to the 5 over x to the 5. That's just 1. So the first piece gives me 3x to the 7th over x to the 5th minus 4 over x to the 5th. And then we could express it as a single fraction with a common denominator of 3x to the 7th minus 4 over x to the 5th. This answer is correct. This answer is correct. It just depends on how one defines simplification to determine which one is preferred. Our next rule is the derivative of some constant k times f of x is just the constant times the function. So we can pull the constant out in front of a derivative operator. So the derivative of 5x cubed. Let's pull the 5 out in front based on this rule. That will be 5 times the derivative of x cubed. And then to do the derivative of x cubed, we're back to our power rule. Pull the exponent down. 3 times x to the 3 minus 1, 3x squared. So we get 5 times 3x squared. And what does that become? It becomes 15x squared, as you would expect using this rule, which enables us to pull the constant out in front of the derivative operator. Our next example is the derivative with respect to x of 7 times the 5th root of x squared. 7 is a constant. 7 can come out in front of the derivative operator. 7 times the derivative with respect to x of the 5th root of x squared. That is x to the 2/5. So we can think of that as 7 times the derivative of x to the 2/5. The top is this exponent 2, the bottom is that one, and the elbow of the radical. Now we can go ahead and use the power rule. The derivative of x to the n is nx to the n minus 1. So the derivative of x to the 2/5 would be 2/5 times x to the 2/5 minus 1. So 7 times 2/5 times x to the 2/5 minus 1. 7 times 2/5 is 14/5. 2/5 minus 1, 2/5 minus 5/5 is negative 3/5. So we get 14/5 times x to the negative 3/5. Let's make this look a little better. X to the negative 3/5 is 1 over x to the 3/5. What does that mean? That means 1 over the 5th root of x cubed. X to the 3/5. The bottom number is in the elbow of the radical. The top number is the exponent. So we get 14/5 times 1 over the 5th root of x cubed. Simplifying that fraction, 14 times 1 is 14. 5 times the 5th root of x cubed. You could rationalize the denominator. I don't see much advantage in doing that, so I will leave that as my final answer. Okay, now we're going to put all these things together. The power rule, the derivative of the sum is the sum of the derivatives, and the pulling out the constant rule to do this problem. So I have the derivative of this large thing. This function plus this function plus this function plus this function. So we know we can take the derivative of the sum as the sum of the derivatives. Derivatives of 8x cubed plus the derivative of 5x squared plus the derivative of 10 times the square root of x plus the derivative of 6 over x to the 5th. If these were minus signs instead of plus, nothing changes. The derivative of the difference is the difference of the derivative. It's just a slight extension on the idea. So that was our first rule. The sum of the derivatives is the derivative of the sum. Now pull the constants out. 8 is in front of the derivative operator. 5 is in front of the derivative operator. 10 will be in front of the derivative operator, and we'll do something with that 6 as well. So you'll notice 8 times the derivative of x cubed plus 5 times the derivative of x squared plus 10 times the derivative of square root of x. This is 6 times 1 over x to the 5th. So I can pull that 6 out. 6 times the derivative of 1 over x to the 5th. And we're getting to the point that we can use our power rule. But first, I'm going to rewrite square root of x as x to the 1/2. And I'm going to rewrite 1 over x to the 5th as x to the negative 5. And now we're going to use our power rule. The derivative of x to the n is nx to the n minus 1. So the derivative of x cubed will be 3x squared. The derivative of x squared will be 2x. The derivative of x to the 1/2 will be 1/2 x to the negative 1/2 when you decrease the exponent by 1. The derivative of x to the negative 5 will be negative 5 x to the negative 6 when you decrease the exponent by 1. So let's show all that. 8 times 3x squared, 5 times 2x, 10 times a half, x to the half minus 1, 6 times negative 5, x to the negative 5 minus 1. Of course, 8 times 3 is 24, so we have 24x squared, 5 times 2 is 10, 10x, 10 times a half is 5, 5x to the half minus 1 to the negative 1/2, 6 times negative 5 minus 30, x to the negative 6. Let's make this look a little bit cleaner. X to the negative 1/2 is 1 over x to the half. X to the negative 6 is 1 over x to the 6th. So we can rewrite it that way. Now, x to the 1/2, of course, is the square root of x. So we can rewrite that this way. Actually, multiplying the fractions first. 5 over x to the 1/2, which will be 5 over the square root of x. And again, you could rationalize the denominator. I don't see much advantage in doing that, so I will not. And that will conclude this lesson.